You're eating meat right now. You don't know why. Not the meal, not the hunger, the deeper thing, the reason you're built to want it at all. That question goes somewhere strange. It goes somewhere most people have never followed it. Because the answer at the bottom isn't about diet. It isn't about health. It's about what made you human. And here's the thing. The first time your ancestors tasted flesh, it wasn't a choice. It wasn't a recipe. It was probably an accident, beside a half-eaten carcass in a place called the Afar region of Ethiopia, 3.4 million years ago, before our genus even existed. But why did it stick? Why did a single bite of scavenged antelope eventually rewire the human body from the inside, shrinking the gut, expanding the skull? Building the brain you're using to read these words? That's the question. And it goes 5 levels deep. Each answer produces a harder one. By the time we reach the bottom, the whole story looks different. Level 1. When? The date most people quote is 2.6 million years ago. That's the number in the textbooks, the number cited in most documentaries, the one that feels settled and official. It comes from a site called Gona in Ethiopia, where archaeologists found stone tools and cut-marked animal bones lying side by side in sediment firmly dated. For decades, that was the floor, the oldest hard evidence, the moment the curtain lifts. Then, in 2010, Zeresenay Alemseged of the California Academy of Sciences published something that moved the floor by 800,000 years. His team had been working a site called Dikika. Same country, same general region, a different layer of rock. They found 2 bones, just 2, bearing multiple linear striations that matched the exact pattern of stone tool-cut marks. Not carnivore gnawing, not geological scratching from river sediment. Actual tool marks, made deliberately, on animal bones, dated to 3.4 million years ago. That number is uncomfortable because of what lived in Ethiopia 3.4 million years ago. The hominin species found in the adjacent Dikika deposits wasn't Homo habilis. It wasn't any member of our genus at all. It was Australopithecus afarensis. That's the species most people know by a different name. Lucy, think about that for a second. The creature whose skeleton has been in museum exhibits for 50 years, the small bipedal ape often imagined picking fruit in the trees. That creature, or something very like it, may have held a sharp stone and sliced meat from a large animal's bone. Whether it hunted or scavenged, we can't say for certain. The researchers themselves noted no tools were found at Dikika, suggesting early hominins may have grabbed naturally sharp rocks and used them ad hoc, the way you'd pick up a flat stone to crack something open. But the marks are there. And the marks are 3.4 million years old. Historians still argue about whether Dikika represents true tool use or opportunistic rock grabbing. But the meat-eating part? That's not really in dispute. So the answer to level 1, the first taste of meat happened at least 3.4 million years ago, probably earlier, probably in the Afar region of what is now Ethiopia, probably by a hominin that looked far more like a chimpanzee than like you. But why did it happen at all? That's level 2. And this is where the comfortable story starts to crack. Level 2. Why meat? Why then? Most people assume our ancestors chose meat because it was nutritious, a deliberate upgrade, smarter apes eating better food. That's not really what the evidence shows. What the evidence shows is desperation with good timing. Around 3 to 4 million years ago, the climate in East Africa was shifting. Forests were contracting. Open grasslands, savannas, were expanding. The fruit and leaves that hominins had been eating for millions of years were getting harder to find. The caloric density of a plant-based diet in an open savanna is genuinely poor compared to what a forest offers. You spend most of your waking hours eating just to stay alive. Meanwhile, large predators were everywhere. Lions, leopards, 3 separate species of saber-toothed cats, including one significantly larger than the biggest African lion alive today. When those animals made a kill, they ate their fill and walked away. What they left behind was enormous. Rob Blumenschine of Rutgers University spent years in the Serengeti and Ngorongoro documenting leftover carnivore kills, and what he found was striking. On a typical lion kill of a zebra, 95% of bones were left with at least some flesh. More than half had significant meat remaining. An average zebra hindlimb has almost 23 kilograms of flesh. Even after a lion takes 90%, that's still 2.3 kilograms per leg. One full zebra carcass, post-lion, could yield nearly 15 kilograms of scavengeable meat. In modern terms, the caloric equivalent of roughly 107 Big Macs, left in the dirt for whoever was clever enough to show up with a sharp rock. Our ancestors were clever enough to show up with a sharp rock. That's the mechanism. Not ambition, not preference. A shrinking forest, a protein gap, and the realization that the landscape was already full of processed carcasses left by bigger, faster animals who didn't know what to do with the marrow. But here's what nobody questions. Why did that one behavioral shift, scavenging beside a dead zebra, scraping meat from a bone with a stone flake, why did that outlast everything? Why didn't it stay a marginal emergency strategy, the way chimpanzees occasionally eat meat at roughly 3% of their diet as a high-effort supplement? Why did it take over? Level 3. Why it stayed. If meat had simply been calories, evolution would have treated it like any other caloric solution. Useful in lean times, abandoned when better options returned. But meat contains something plant foods don't. Not just protein, not just fat. Vitamin B12, which is essentially absent in plants and which the human nervous system requires to function. Docosahexaenoic acid, one of the most abundant fatty acids in the human brain, found in dense concentrations in the brains and marrow of large animals. Iron in its heme form, which the body absorbs at a rate 4 to 5 times higher than the non-heme iron in plants. Zinc, calcium, vitamin K2. Here is what the expensive tissue hypothesis, developed by Leslie Aiello of University College London and Peter Wheeler of Liverpool John Moores University in 1995, actually argues the human body could not have evolved a larger brain without simultaneously shrinking the gut. These are both metabolically expensive organs. Brain tissue and gastrointestinal tissue consume enormous amounts of energy. You can't scale up one without scaling down the other. And you can only scale down the gut if the food coming into it is dense enough, pre-processed enough, easy enough to digest that you don't need meters of intestine to extract nutrition from it. Cooked plants get you partway there, but raw, high-quality animal tissue, muscle meat, organ meat, bone marrow, is digestively efficient in a way raw plants simply aren't. So meat didn't stay because our ancestors liked it. It stayed because the bodies that processed it efficiently were the ones that had energy left over for neurology, the ones with better tools, the ones who survived, and the ones who didn't eat enough of it gradually lost the competition. By around 2 million years ago, we see this written directly into the fossil record. Homo erectus appears, and compared to everything that came before, this species is startling. Taller, bigger-brained, smaller-jawed, shorter gut, longer legs for covering distance. The whole body is configured differently, and the difference correlates precisely with increased, systematic meat eating. A 2021 study from Tel Aviv University, reviewing multiple lines of fossil and isotopic evidence, concluded that early Homo spent roughly 2 million years as what they called hypercarnivorous apex predators, placing them at the top of the food chain alongside lions and saber-toothed cats, not beside grazing herbivores. If that rearranged something in your head, hit like. It genuinely changes whether this kind of content reaches anyone, but we're only at level 3, and the deeper we go, the stranger it gets. Level 4. Why the brain? Let's name the thing nobody says out loud. The question isn't just what did meat do to our bodies, the question is what did it do to our minds? What did 2 million years of hunting, scavenging, tracking, cooperating, planning, and processing carcasses actually build inside the skull? Because when you look at the timeline, meat eating and cognition don't just correlate. They seem to drive each other. Around 1.95 million years ago, at a site called Koobi Fora in Kenya, researchers found evidence that hominins were butchering not just land mammals but aquatic animals, turtles, crocodiles, fish. This matters because aquatic animals, especially fatty fish, are among the richest known sources of the long-chain polyunsaturated fatty acids the brain requires for growth. Josephine Joordens of Leiden University argued in 2014 that this shift toward aquatic food may have provided the specific lipid compounds needed to support the first significant jump in brain size around 2 million years ago. Think about what hunting a crocodile requires compared to scavenging a lion's leftovers. The crocodile is alive. It fights back. You need to predict its behavior. You need to coordinate with others. You need to plan the approach, assign roles, read the environment, communicate in real time. Every step of that process selects for better cognitive wiring. And then, after you've killed it, you need to remember where you catch the bones, return to them days later, and break them open for marrow, a behavior documented at Qesem Cave in Israel roughly 400,000 years ago, where researchers found evidence that hominins were storing deer bones for up to 9 weeks before cracking them open, essentially using the animal's own bones as sealed containers for fat-rich food. Planning, memory, delayed gratification, social coordination. These aren't byproducts of meat eating. The argument, and it's a serious one, is that they're requirements. You can't hunt at scale without them, and the selection pressure of hunting at scale is part of what built them, which means the brain you're using to follow this argument may have been built, in part, by the demands of getting meat. Hold on. Pick a side before we keep going. Which came first to your mind? Did the bigger brain lead to better hunting, or did better hunting lead to the bigger brain? Drop your answer. There's no consensus. Scientists still argue about this. Level 5. Why this matters now. Here's where we have to pause. Because Level 4 already contains a reversal, and it changes what Level 1 means. We started with a simple question. When did humans first taste meat? The answer seemed to be about chronology. A date. An event. 3.4 million years ago. Dikika, Ethiopia. A sharp rock. A dead antelope. But look at what we actually uncovered. Meat didn't enter the human story as a food. It entered as a transformation engine. Every time our ancestors increased their access to animal tissue, from occasional Australopithecus scavenging to systematic Homo habilis butchery at Kanjera South 2 million years ago, to Homo erectus taking prime cuts from carcasses at Koobi Fora 5 million years ago, to Neanderthals tested by stable nitrogen isotope analysis at Vindija Cave in Croatia, whose results placed them squarely among apex carnivores, every increase corresponded to a reorganization of the body and the brain. The first taste of meat wasn't a meal. It was the first iteration of a feedback loop that ran for 3 million years and didn't stop until the brain tripled in size, the gut shrank, the jaw narrowed, fire was controlled, food was cooked, and a species emerged that could, among other things, wonder why it was built the way it was. And fire is where the story closes the loop entirely. There are hints of fire use dating back to between 1 and 2 million years ago in eastern and southern Africa. The first solid, unambiguous evidence comes from Wonderwerk Cave in the northern Cape of South Africa. Bits of ash from burnt grass, leaves, and bone fragments, dated to approximately 1 million years ago. By 790,000 years ago, at a site called Gesher Benot Ya'aqov in Israel. Hominins were returning repeatedly to the same hearths, cooking over early campfires, burning wood alongside edible plants, including wild barley, wild grape, and olive. Cooking changes meat chemically. It breaks down collagen. It denatures protein structures, making them easier to absorb. It kills parasites. It increases caloric availability from the same mass of food. Richard Wrangham of Harvard University, who spent decades on this question and wrote the 2009 book Catching Fire, argues that cooking was the single most important dietary event in human evolutionary history, more transformative even than the initial shift to meat. And when you look at the fossil record, the biggest single jump in human brain size appears right after the earliest firm evidence of cooking. Right after. So the full answer to when did humans first taste meat is not a single moment. It's a direction. A 3.4 million year escalation from an opportunistic bite beside a predator's kill in Ethiopia, through systematic scavenging, to strategic hunting, to apex predation, to fire and cooking, to a brain large enough to reconstruct the whole process and ask why it happened. Every meal is a very old habit. Every bite of meat you've ever taken carries 3.4 million years of biological momentum behind it. The question isn't when we first tasted it. The question is, what would we be if we hadn't? Subscribe if you want to be there for the next one, because the next question on this ladder gets weirder. That last thought, the thing we'd be if meat had never entered the story, I'll leave it sitting in the room. Not as a conclusion, as a weight. Because you are almost certainly alive and thinking and capable of asking questions precisely because something 3.4 million years ago didn't have enough fruit to eat. What's another everyday thing you do that nobody ever questions where it came from? Leave it below. The best ones are going to become their own episode.